As scientists and astronomers peer more closely and with ever more fidelity at nearby stars, they are discovering exoplanets, worlds outside our own solar system. Stars with planets were once thought to be a rarity. They are turning out to be the norm and not the exception. With some confidence, scientists now calculate there could be as many as 40 billion Earth-like planets in our Milky Way galaxy alone. The first exoplanets were detected in 1992, orbiting a pulsar, the remnants of a massive exploded star that was now a fast-spinning neutron star. With data collected from the Arecibo antennae in Puerto Rico, Alexander Volshan discovered 3 terrestrial planets orbiting the pulsar PSRB 1257+12. Other pulsars have been detected with dust clouds and disks orbiting them. This suggests that these 3 planets are second generation. The original planets were destroyed by the stellar explosion, and the subsequent debris disk enabled these new planets to form. It was another 3 years before the first planet orbiting a G-class star similar to our Sun was identified, a gas giant like Jupiter orbiting 51 Pegasi every 4 days. 5 years later, another main sequence star was found to have multiple planets. Exoplanets were not easy to detect. They are tiny, their light smothered by the light of their star, and they are so far away. There are 3 main methods for planetary detection. The hardest is direct visual observation via telescope, both on the ground and in orbit. Some 59 planets have been discovered this way. More indirect methods are employed, one of which is the radial velocity method. As a planet orbits, its gravitational pull causes the parent star to move back and forth. This tiny radial motion shifts the observed spectrum of the star by a correspondingly small amount because of the Doppler shift. With supersensitive spectrographs, the shifts can be measured and used to infer details of a planet's mass and orbit. The 3.6-meter telescope at La Silla, Chile, has such a spectrographic instrument called HART and is the leading exoplanet hunter. This is Tau Boötis, one of the first planets discovered utilizing this method. 51 light-years from Earth, this planet is massive, some 4 times the mass of Jupiter. So far, over 600 planets have been detected by this method. Another observational tool, and the most successful to date, is the transit method. A planet that passes in front of its parent star relative to us produces a slight dimming of the star's light, which can be detected by sensitive instruments. Some 1,200 have been located this way. Until now, it was expected that exoplanets would orbit in more or less the same plane and in the same direction as the star's rotation. However, new results unexpectedly show that many exoplanets actually orbit at a large angle to their star's spin axis. In the case shown here, WASP-8b, the orbit is completely reversed. There are other tools and techniques in the planet hunting toolbox, including microlensing, occultation and TTV or transit timing variation. Often more than one technique is used to verify findings. In fact, revisiting a planet after some time for verification can lead to surprising results, as in HD 189733b, a hot Jupiter-type planet. On revisiting it, Hubble discovered the atmosphere was being stripped from it by a violent stellar flare. With the Hubble Space Telescope dividing its valuable time between many varied tasks and objectives, a dedicated planet hunter called Corot was launched. The mission was led by the French space agency, CNES, with contributions from ESA, Austria, Belgium, Germany, Spain and Brazil. Launched in 2006, the mission lasted 7 years. It located 2 planets around the star Corot 7, one of which was the first found to display a density similar to Earth's. In all, it located 32 planets, and 100 others are awaiting confirmation. The NASA Spitzer infrared space telescope was launched to study protoplanetary and debris disks around stars and the curious brown dwarfs, often referred to as failed stars. Spitzer's infrared capability quickly led to numerous planetary discoveries and infrared mapping of other known planets, like hot Jupiter HD 149026b. Some 256 light-years away in the constellation Hercules, a planet dubbed a hot Jupiter, it is a sweltering 2040 degrees Celsius, the hottest planet yet detected, and also the darkest, reflecting no sunlight back into space. It speeds around its star every 2.9 days. A world just 2/3 the size of Earth, one of the smallest on record, and only 33 light-years away around the star GJ436, planet UCF-1.01 might be the nearest world to our solar system that is smaller than Earth. The planet, a rocky world, orbits so close to the star that the surface is probably molten. As with HD 189733b in the constellation Vulpecula, it appears to be tidally locked to its star, showing only one face as it orbits. Spitzer was able to distinguish the various temperatures of its clouds from 650 to 1700 degrees Celsius. Thermal imaging of these hot giants has provided more details of these distant worlds. In 2009, the game changed with the launch of the Kepler Space Observatory. As part of NASA's Discovery program, the Kepler Space Telescope was launched to survey and monitor a fixed field of stars of the nearby Milky Way trailing behind Earth. It observed around 165,000 stars, watching for any changes in their brightness. It has located over 1,100 planetary candidates.
Now these are candidates, but most of them, I'm convinced, will be confirmed in the coming months and years. That's more than all the people have found so far in history.
A veritable menagerie of planet types is emerging, like Kepler 16b, orbiting 2 stars, ice worlds and water worlds like Gliese 1214b.
The Kepler team announced today 1,094 new planet candidates, bringing the total roster up to 2,326. Of those, 207 are Earth-size, and we now have 48 that are in the habitable zone, 10 of which are smaller than 2 Earth radii. So these are planets that could potentially be rocky. So it's an exciting milestone because we are really honing in on truly Earth-sized habitable planets.
The combined surface and space-based system observations have led scientists to believe that planets around stars are the rule rather than the exception, and the average number of planets per star is greater than 1. Kepler has discovered at least 86 stars with multiple planetary systems. Kepler 11, for example, has 6 confirmed planets orbiting a Sun-like star.
The Kepler-11 planetary system is amazing. It's amazingly compact, it's amazingly flat. There's an amazingly large number of big planets orbiting close to their star. We didn't know such systems could even exist. There's certainly far fewer than 1% of stars have systems like Kepler-11. But whether it's 1 in 1,000, 1 in 10,000, or 1 in a million, that we don't know, because we only know one of them.
The growing number of confirmed planets is opening up new insights into planet formation.
We're learning so much more about the orbits of planets, the masses of planets, the sizes of planets, and we're just beginning. Kepler is still returning data, and we're going to learn a fantastic amount about the diversity of planets out there around stars within our galaxy.
Around each star is a circumstellar region called the habitable zone. Sometimes referred to as the Goldilocks zone, this is a region neither too cold nor too hot, where a planet could, under the right conditions, support liquid water at its surface, and in turn could support life. The first Earth-sized planet in a habitable zone was discovered around a red dwarf. Named Kepler 186f, it is just 10% larger than Earth.
Kepler 186f is the first validated Earth-sized planet in the habitable zone of its star. It's the outermost of 5 planets to orbit a star that is smaller and cooler than the Sun. This planet orbits its star every 130 days, and so this places it in the habitable zone, where it's in a region where it could have liquid water on its surface.
The star Kepler 186 is 500 light-years from Earth in the constellation Cygnus.
This planet, Kepler 186f, orbits a star that's cooler and dimmer than the Sun. So while we may have found a planet that's the same size as Earth and receives a similar amount of energy to what Earth receives, it orbits a very different star. So perhaps instead of an Earth twin, we've discovered an Earth cousin.
Believed to be a rocky world, its mass and density are yet to be determined.
This is one of the big milestones that we've been looking for in our attempts to find out if there are places just like home and if there's life out there. One of the big steps is to say, is there somewhere that looks, to all intents and purposes, like Earth? Well, we don't know just yet, but we know that there are places that at least look similar.
To date, over 48 Earth-like planets have been located within habitable zones. Gliese 581 has 4 known planets. The outer D planet is thought to be an icy planet that has migrated closer to the star and would thus be covered by a large and deep ocean. Kepler 62f is likely to have a rocky composition and is only 40% larger than Earth, making it the exoplanet closest to the size of our planet known in the habitable zone of another star. Kepler 62e orbits on the inner edge of the habitable zone and is roughly 60% larger than Earth. Other recent discoveries include Kepler 438b, 442b, and 440b, a super-Earth. The super-Earth exoplanet GJ1214b orbits its faint red parent star. This is the first super-Earth exoplanet to have had its atmosphere analyzed. It has a mass about 6 times that of the Earth and appears to be surrounded by an atmosphere of steam or thick clouds or haze. Based on observations, scientists believe that of the Sun-like stars, some 22% have an Earth-sized planet orbiting in the habitable zone. Assuming 200 billion stars in the Milky Way, that would be 11 billion potentially habitable Earths, rising to 40 billion worlds if brown dwarfs are included. Are any of these worlds close to Earth? In fact, yes. The closest star to our own is the well-known Alpha Centauri group, with the bright stars Alpha and Beta Centauri, plus the faint red star Proxima Centauri, the closest star to Earth. Alpha Centauri b is known to be orbited by an Earth-mass planet, making it the closest exoplanet to our solar system, a mere 4.37 light-years away, almost within our reach. Now in its fourth observing campaign, the Kepler spacecraft continues targeting 16,000 stars for exoplanets. It's estimated that the onboard fuel supply should last until at least December 2017. So far, Kepler has found an astounding 1,013 confirmed exoplanets around 440 star systems. The terrestrial telescopes continue to do the heavy lifting when it comes to verifying possible planet candidates. The HARPS spectrographic instrument at La Silla, Chile, is being joined by the Next Generation Transit Survey, or NGTS. It will search for transiting exoplanets with a focus on discovering Neptune-sized and smaller planets. NGTS is designed to operate in a robotic mode. It will continuously monitor the brightness of hundreds of thousands of comparatively bright stars in the southern skies. ESO's Very Large Telescope at Cerro Paranal in Chile, composed of 4 individual telescopes, will be improved with the new next generation of adaptive optic system called SPHERE. Other improved technologies include the Gemini Planet Imager at nearby Cerro Pachon, now in operation, and the Subaru Coronographic Extreme technology currently being installed and tested. New, bigger and more powerful telescopes are in the pipeline as well. The 30-meter telescope planned for Mauna Kea, Hawaii, will have 492 small hexagon mirrors arranged together to form the primary mirror 30 meters across. The GMT, or Giant Magellan Telescope, will be built at the Las Campañas Observatory in Chile. It will consist of 7 8.4-meter mirrors arranged together to make up the primary mirror. Work on the mirrors is well underway. The European Extremely Large Telescope in the Atacama Desert is due for completion in 2024. It will have a 39-meter diameter mirror made up of 798 hexagonal mirrors and will be the largest ever built. It will enable scientists to study the atmosphere of exoplanets more closely. Space-based telescopes are advancing as well. The next generation infrared telescope, James Webb, is nearing completion as it goes through rigorous testing. A scheduled launch in October 2018 will put the 6.5-meter telescope in orbit as a replacement for the Hubble and Spitzer telescopes. Likened to the California gold rush, there are planets out there to be found, and the race is on. TESS, the transiting exoplanet survey satellite, is scheduled to launch in 2017. TESS will scan the entire sky, searching for exoplanets using 4 state-of-the-art cameras. It will be able to determine the chemical compositions of exoplanet atmospheres. Also planned for a 2017 launch is Cheops. Its function is to characterize transiting exoplanets orbiting bright host stars. The satellite is a small package, roughly 1.5 meters square, with a life expectancy of 5 years. The European Space Agency has commenced a new program called Cosmic Vision, set to run from 2015 to 2025, with Plato, an exoplanet hunter, expected to be launched in 2024. Other projects underway include Pégase, under development in France, Exceed, the Exoplanetary Circumstellar Environments and Disk Explorer from NASA, and Finesse, the Fast Infrared Exoplanet Spectroscopy Survey Explorer, due to launch 2019. The Wide Field Infrared Survey Telescope, WFIRST, is another NASA observatory designed to perform wide-field imaging for the planet-hunting community. It will be fitted with a coronagraph instrument for direct imaging of exoplanets and debris disks. Another NASA New Worlds mission is the Star Shade project, scheduled for a 2019 launch. It will physically block the star's light with a parasol to allow direct observation of exoplanets. NASA is already thinking about a future James Webb replacement. Called the Advanced Technology Large Aperture Space Telescope, or ATLAST, it will be 2,000 times more light-sensitive than Hubble. If all goes according to plan, ATLAST could be launched between 2025 and 2035. With these new tools and technologies, it is only a matter of time before we are able to detect Earth-like worlds capable of supporting life. Perhaps one day, even a planet emitting radio or other signals indicative of a sufficiently advanced intelligent civilization. Finally answering that great question, are we alone?